Today is Wednesday, the 7th of November, 2018. It's about 8 o'clock in the evening, and I'm going to give a short demonstration explanation of my findings so far with this tempo velocity printed circuit board, which is mounted right here on this little fixture. On the back of the fixture there is a Quantum Devices QD145 encoder, 1250 counts per revolution, and that's feeding into this buffer board here, which is taking the two channels and basically converted into a 4-channel line drive. And I am running two of the channels into the buffer board, or from the buffer board into the tempo velocity board, and I'm running the other two channels into this counter over here. And this counter is set up in it's set up in ×4 counting mode, so we're seeing basically 4 times the output from the encoder in here, and counting just counting pulses. This is being fed by this Agilent meter up here, which is set at 5 volts. It's currently drawing 1/4 of an amp, and that's what it typically draws. The output from the tempo velocity board is being fed into this display right here, and you can see it's kind of erratic. I also have this Rigol scope looking at the output, and basically the output that we're seeing is kind of a crazy square wave that bounces up and down between a plus and minus voltage, and you can see we're seeing that here, although it's mainly plus rather than minus. And I'm driving it with this motor, and the motor's is not fixed particularly, so you can see on the counter the speed bounces around here by maybe 100 to 200 counts, but certainly not 1,000 counts, which the scope would indicate is happening. And I can adjust the output speed, and I can take it up here. I'm on I have switch number 1 on the board, on the tempo board, set, and switch number 2 is still at 0, which means that I should be good to 10,000 counts on this meter. But in fact, what I'm finding is that at some point, and I'm going to say the voltage will go up, and then it'll just all of a sudden peg at 10 volts when I'm only running about 5,800, 5,900 counts per second on the display. And you can see over here the Rigol scope is now pegged, and I'm going to bring that speed down a little bit, and it'll go back into, as I bring it down, it'll go back into sort of the square mode pulse. There it's fallen out to 0, but I think I stopped it. And so you can see how that goes. It's kind of a strange output. And yet, this board, the output of it is quite solid. When I remove the encoder and place the jumper in place and use the self-generated encoder signal. The other thing is that the output voltage, currently what I'm doing is powering the encoder with the 5 volts coming out of the display here. And the reason for that is because the 5 volt output from the tempo board, as soon as you put any serious power on it, which is about 80 milliamps, is about all the encoder and this board over here is drawing. So you need to put that onto it. The voltage immediately drops down to around 3 volts, and the display current draw goes up to about 320 milliamps or so, 320 to 360 milliamps, and it stays there. You can shut the power off, turn it back on, and it'll still be pegged at 360 milliamps even if the encoder is disconnected. And it takes a few seconds, I'm not sure exactly how long, maybe about 10 seconds or so, for the power to be off, and so that when you bring it back up, you come back up with 5 volts and 240 milliamps. Anyway, that's a quick explanation of where we're at.